Look at this side-by-side comparison. On the left, we have the most common way people interact with AI, typing out a massive, chaotic clump of text. The result is almost always a generic, unusable wall of information. People assume that giving an AI a higher volume of words naturally gives it better context. In reality, a rambling paragraph dilutes your core instruction. The AI loses track of what you actually want it to do. Instead of typing paragraphs, we can organize our requests through a 3-part schematic: APE, action, purpose, expectation. It takes about 20 seconds to write. Filtering your instructions into a constrained, linear path removes the guesswork. You tell the model exactly what the task is, and it returns a practical, ready-to-use document on the very first try. By expanding the A node on this diagram, we see exactly what an action is. You must pair a precise verb with a concrete product. You write "generate 8 questions" or "analyze a paragraph." Moving to the P node, purpose defines your strict use case. This tells the AI why you need the product. You explain if the output is for a projector model, a small group research task, or a 5-minute student conference. The final E node acts as your bounding box. Expectations set the hard limits on the output. You define word counts, specify dot points, enforce a plain language tone, or dictate that no new content can be added. This strips away unwanted paragraphs. This structure directly mirrors clear pedagogical instruction. By feeding the AI the exact what, why, and how, the system stays completely focused on your targeted outcomes. If you submit a vague request for questions on medieval history, the AI will spit out random trivia. Under the APE framework, your action becomes generate 8 retrieval questions on medieval Europe. Your purpose is activate prior knowledge for a Year 8 mixed literacy class. To make that history output instantly usable, we filter it through expectations. We require 4 short answer questions and 4 multiple choice. We ask the AI to label difficulty levels, include an answer key, and format everything to fit on exactly half an A4 page. If we pause the sequence and build a prompt using only action and purpose, we hit a friction point. The AI knows what to make and who it is for, but without the expectation block, it has no finish line. Missing that final step causes the AI to default to its baseline programming. It fills the space by writing a dense, unformatted essay that you cannot hand to a Year 8 student without spending 10 minutes retyping it. Defining strict constraints up front prevents AI bloat. It forces the system to do the formatting work for you, creating a document you can immediately copy, paste, and print. We can use this Brie-column troubleshooting matrix to fix failed prompts. In the first column, if you receive a generic output, your action verb was too vague. In column 2, if the output is completely off target, it points to a purpose failure. You didn't tell the model exactly how you intended to use the material. And in the final column, if your output is messy or excessively long, your expectations failed to provide tight formats and limits. For highly specialized outputs, you can attach a persona modifier to the very beginning of the APE spine. You instruct the AI to act as an ATAR marker or act as a curriculum designer to establish a specific vocabulary before running the rest of the prompt. APE is designed for quick tasks you can execute on the fly. For multi-step workflows like deep data analysis or drafting full-term lesson plans, you will need to transition to heavier master structures like the Ryzen framework. Setting up 3 lines of constraints takes a few seconds. In return, the generative AI stops behaving like a conversational chatbot and operates as a reliable precision tool.